NASA unveiled pictures from a new space telescope capturing the deepest images of the universe anyone has ever seen.
From Fox 35 Mission Control, an out-of-this-world discovery. NASA says it just found a new planet.
Shocking, right? Yeah, the James Webb telescope spotted it just outside of our solar system.
For decades, astronomers have peered into the dark vastness of space, threading together the story of the universe from glimmers of distant starlight and patterns written across the night sky. The unknown beckoned, but its secrets always felt just out of reach, lodged amid distant galaxies, measured in redshift and parsecs, deduced through finely tuned calculations and careful theory. All of that is now undergoing a transformation thanks to the James Webb Space Telescope. The James Webb Telescope, or Webb as it's known, has peeled back the curtain on cosmic history with unprecedented sensitivity. Where astronomers once expected the grand narrative of galaxy evolution to align neatly with established theory, Webb's observations suggest that the universe's history might be far stranger, richer, and more complex than ever anticipated. What once felt immutable, the slow march of time, the rules governing when and how galaxies spark into being, now seems flexible. The edge of what we knew has become blurry. In regions of space previously catalogued as ordinary, Webb has found galaxies, objects, and structures that appear to defy conventional models. This isn't merely a matter of finer detail, it is a challenge to fundamental assumptions about the timing and mechanisms of cosmic evolution. Even the very language of astronomy is shifting. Terms like early, young, or primordial no longer capture the strangeness of these findings. Webb is not only revealing galaxies where none should yet exist, it is exposing them in unexpected maturity, with star systems, heavy elements, and orderliness that contradict the slow, deliberate pace theorists once envisioned. The telescope has, in effect, turned back the clock and found the universe behaving like a restless artist, sketching whole structures in strokes that seem far too fast for the canvas of cosmic time. The impact has been immediate. Long-standing computer simulations, those digital laboratories where cosmologists replay the Big Bang and watch virtual universes unfold, are straining under the weight of Webb's revelations. The simulations predicted a gradual crescendo, but Webb's data plays more like a sudden overture, galaxies blazing into existence long before their scheduled appearance. From galaxies that seem too mature for their own epoch to new discoveries within our own galactic neighborhood, Webb is forcing scientists to question what they thought was certain and to confront surprises that were once dismissed as impossible. The impossible anomaly. Many recent breakthroughs began quietly, hidden in data collected during routine observations. In one such case, astronomers undertaking a systematic re-examination of a distant galaxy cluster found something that stubbornly refused to blend into the cosmic background. Using its extraordinary clarity, Webb spent over 100 hours revisiting an extragalactic field first immortalized by the Hubble Space Telescope. Where Hubble's iconic deep fields mapped thousands of galaxies, Webb's sharper vision peeled away layers of cosmic dust and redshift, exposing finer details. Within this web of distant starlight, researchers noticed a signature, a luminous, apparently mature galaxy at extreme distance, confronting them with a puzzle. This was not an isolated artifact in the data. Repeated observations cemented its reality. The more they studied it, the stranger it became. Its light carried telltale chemical fingerprints. Oxygen, carbon, even traces of heavier elements that implied generations of stars had already lived and died. Such enrichment should have required hundreds of millions of years of stellar births and supernova deaths. Yet the timeline suggested the cosmos itself had barely begun to organize. This object shone back from a time just 300 million years after the Big Bang, a period when, according to established cosmic models, galaxies should have been faint, unorganized, and only beginning to coalesce from primordial hydrogen. Yet here was a galaxy not only visible, but shining with the brightness and structure of a much more mature system. Its spiral-like features suggested order, not chaos. Its mass rivaled galaxies billions of years older. The anomaly forced uncomfortable questions. Were our measurements of distance wrong, the redshift misinterpreted, or was something far deeper at stake? That our entire chronology of the early universe was missing a chapter? The latter possibility sent ripples through the astrophysics community. The spectroscopic evidence was unequivocal. I existed before I should have, and I should not be this bright. With every new observation, the anomaly sharpened, presenting itself not as an outlier, but as a sign that our script for how the universe should evolve might be incomplete. It was as though the universe itself whispered back, "The rules you wrote for me are not the rules I follow." A new kind of archaeology. As the Webb's Jade survey pressed further, a pattern emerged. These mature galaxies, shining brightly from the ancient universe, were not unique cases. Across the deep field, Webb uncovered multiple galaxies whose mass, brightness, and surprisingly organized structure challenged standard cosmological timelines. The expectations had been different. Astronomers anticipated glimpses of dim, amorphous clouds, faint whispers of the epoch when the cosmos was a turbulent sea of cooling hydrogen. Instead, they found beacons, galaxies whose disks and star clusters seemed to defy the chaotic, slow assembly history once thought certain. It was as if the engines of cosmic creation had revved up unexpectedly early, sparking complexity at a pace that defied tradition. This unexpected evidence set off vibrant debate. Was there a fundamental flaw in our galaxy formation models? Or did the rules of cosmic structure and time allow for a wider range of possibilities than theorists had supposed? Webb's infrared capability not only looked farther, but in greater detail, extracting chemical signatures that showed these galaxies were already enriched with heavier elements, carbon, oxygen, and more. Such enrichment means generations of massive stars had lived, died, and exploded, seeding the cosmos in a period far shorter than thought possible. The question grew sharper. If the early universe could build galaxies with such speed and coherence, how many more of our assumptions about its infancy are due for re-examination? A timeline torn, rethinking everything. Webb's discovery of mature galaxies at impossibly early dates has forced a reconsideration of the universe's cosmic clock. The long-accepted narrative described a universe that, after the Big Bang, entered a deep, dark age before igniting its first stars, and only gradually matured into the complex galaxy clusters seen today. Now, solid data suggests that in at least some regions, this timeline is compressed. Galaxies formed faster, brighter, and more intricately than expected. The scientific community's reaction was intense. Some called for complete overhauls of the computer simulations that have until now matched observed structures within later epochs. Others speculated that cosmic inflation, the rapid expansion that smoothed and stretched the early universe, may have allowed pockets of extra density, jump-starting galactic formation far sooner in isolated regions. Hypotheses multiplied. Could dark matter have played an even greater role in rapidly organizing galactic structure? Had unforeseen processes, possibly even phenomena not yet embedded in our physical equations, accelerated the genesis of stars and the assembly of galaxies, as more Webb data poured in, these questions took on greater urgency. Each additional scan deepened the mystery, suggesting that our models of early cosmic history must now adapt to findings that a generation ago would have seemed unthinkable. The once clear-cut line between theory and evidence was now blurred, unsettled by Webb's revelations. Fossils out of time. In parallel with these discoveries, Webb revealed another kind of marvel: fossil galaxies, systems that had ceased star formation billions of years ago, yet whose light was only now reaching us from the universe's formative years. These cosmic relics are snapshots of a rapid period of stellar birth and death, preserved as if frozen in cosmic amber. Unlike their more active neighbors, these fossil galaxies show no evidence of ongoing star formation. Their starlight faded, carrying information about their chemistry and motion from an epoch otherwise unreachable by previous telescopes. These remnants suggest not a slow and steady assembly of structure, but a universe of surprises, where whole galaxies might burst to life, exhaust their fuel, and settle into quiescence while the universe itself was still very young. Such finds serve as time capsules, allowing researchers to dissect, with forensic precision, the early chemical and structural evolution of galaxies. Every element detected, each subtle spectral feature, becomes a clue to the processes shaping the cosmos at its youngest. Like archaeologists uncovering artifacts that challenge prior timelines of civilization, Webb's detection of fossil galaxies has given physicists a new laboratory to measure cosmic dawn. Their implications are profound. The first wave of cosmic building blocks, stars, heavy elements, and dust may have cycled through incredible sequences long before the Milky Way or our solar system formed. A planet closer than we dreamed. Webb's remarkable reach goes both far and near. While its main design enables unprecedented views of the ancient cosmic past, its capabilities have also contributed closer to home. Astronomers using Webb have found strong new evidence for a giant planet orbiting a star in the nearest stellar system to our Sun. The star in question, Proxima Centauri, had long been a target in the hunt for exoplanets. Ground-based studies and prior telescopes offered hints, but now Webb's sensitivity in the infrared allowed astronomers to confirm a signal consistent with a giant planet orbiting this neighboring star. The detection, while not made through direct imaging, emerges in the gentle dimming of starlight as the planet crosses in front of or passes behind its parent star, a technique refined by Webb's precision. This planet, large and previously undetected, forces a recalibration of how thoroughly we've surveyed even our local stellar neighborhood. If a massive exoplanet can orbit undiscovered in the star system next door, what else have we missed? This revelation doesn't just fill in a gap, it reopens fundamental questions about planet formation, the likelihood of finding similar or even more hospitable worlds nearby, and the reality that even in well-studied celestial territory, new discoveries await. Importantly, while Webb is not primarily a life search observatory, its success at uncovering new planetary evidence so close to home suggests the census of nearby exoplanets is just beginning. Smaller, Earth-like planets, especially those that might harbor the right conditions for life, are likely still hidden from view, awaiting the next breakthrough. Maps that rewrite the cosmos. Webb's discoveries are already shaping the very maps with which astronomers chart the universe. Nowhere is this clearer than in the most recent deep field maps produced by the Cosmos Collaboration, powered by new Webb observations. These maps reveal not just thousands of galaxies, but complex hierarchies and alignments previously masked by cosmic dust or lost to the limits of earlier telescopes. Webb's extraordinary resolution has allowed scientists to trace the skeleton of cosmic structure, the threads and filaments along which galaxies cluster and dark matter accumulates at a level of detail never before achieved. With this higher precision, models that once explained the large-scale structure of the universe now encounter new challenges. Entire regions appear denser or more intricate than predicted. Galaxies are more evolved, clusters more sharply defined, and voids more pronounced than previous data indicated. These findings compel a fresh look at how gravity, dark matter, and perhaps other less understood forces have orchestrated the evolution of cosmic architecture. Webb's mapping not only uncovers the hidden architecture of the early universe, but also raises questions about what unseen influences might be shaping it still. When time blinks, each major Webb discovery on its own poses significant questions. Perhaps the most profound, however, involves not objects or structures, but the flow of time itself. The conventional arrow of time, the progression from cosmic chaos to order, from hydrogen gas to star-forged diversity, appears less tidy when scrutinized under Webb's gaze. Some galaxies captured in Webb's observations appear both ancient and active, carrying the chemical fingerprints of astrophysical processes that under standard models should require far longer to unfold. Astronomers are now forced to consider the possibility that the rhythm of cosmic evolution varies more than previously thought. The presence of heavy elements in very early galaxies indicates that stars had already lived and died before such chemistry should have been possible. Have there been rapid cycles of stellar birth and death, compressed timelines dictated by local conditions or other, more complex rules at play? The upshot is a cosmos where the pace of change can flicker, even jump. Galaxies can appear old before their time, and processes thought to require 1 billion years might sometimes play out in a fraction of that span. This implies a flexibility, even a restlessness in the laws of cosmic evolution. Are we missing some entire chapter in the universe's early history? Have critical events, perhaps seeded by dark matter or even more exotic processes, accelerated the chemical enrichment and maturation of the first galaxies? Whatever the answer, Webb has exposed a universe that doesn't always follow its own timelines. Clarity in the veil, decoding light. Webb's power lies in its ability to collect light at infrared wavelengths, allowing it to see through cosmic dust, behind veils that rendered some of the earliest structures invisible to previous telescopes. In these veiled regions, Webb picks up the spectral fingerprints of elements and molecules made in the hearts of stars and the primordial soup of the early cosmos. It is here that some of the most important surprises have come, where theory indicates that the earliest galaxies should be composed almost entirely of hydrogen and helium, too new to boast heavier elements. Webb has found evidence to the contrary. Even some of the universe's first galaxies show the clear presence of more complex chemistry: carbon, oxygen, and other metals. These are the building blocks for dust, planets, and ultimately, life. This suggests that as soon as galaxies began to assemble, the cycles of birth and death in massive stars, stellar nucleosynthesis, were already well underway. The very elements that would later form planets, and eventually, the ingredients of life, seem to have been forged with surprising haste and efficiency. It remains uncertain how many generations of massive stars preceded these discoveries, or whether new types of stellar evolution played a role. The chemical stories told by Webb's infrared spectra propose that cosmic chemical evolution may be more dynamic and more widespread than previously thought. In time, Webb's ability to probe for organics, water, and prebiotic molecules in these distant galaxies may reveal even more about the commonality of life's ingredients in the universe's earliest days. Limits shattered. There is a term, impossible object, applied in astronomy to observations that resist easy explanation, forcing theory to adapt. With each data release, Webb is expanding that category. Galaxies seen shining in a time when none should exist. Planets discovered in previously well-studied stellar systems. Fossil galaxies preserved from the dawn of time, and cosmic maps that reveal complexity and structure where models predicted only diffuse matter. With each new puzzling result, the universe's secrets grow deeper. Models once trusted to explain star and galaxy formation are now open to sweeping revisions. Theories about dark matter's behavior, cosmic expansion, and even the basic clockwork of time are now in flux. Astronomy's journey is not about reaching final answers, but about confronting new, better questions. Webb is pushing our frame of reference from the certainty of well-understood phenomena to the embrace of fresh mysteries and possibilities, the edge of exploration. Astronomers now find themselves at a scientific frontier. Every new Webb survey and data analysis brings findings that challenge or even invert former certainties. Anomalies accumulate, unexpectedly mature galaxies observed near the universe's beginnings, structures mapped with complexity far exceeding expectations, evidence of rapid chemical enrichment, and unexpected planetary neighbors. The universe is not just a tapestry waiting to be catalogued, but a dynamic, evolving story, full of surprises that defy the limits of our current models. Physicists and cosmologists propose new ideas. Perhaps the rules of cosmic structure are more flexible. Perhaps hidden physics or heretofore undiscovered processes shaped the early universe. Maybe new forms of dark matter or energy or unexplored interactions between galaxies are responsible for these patterns. What is increasingly clear is that the universe is not only vaster, but more intricate and surprising than imagined. With each Webb data release, the lines between known and unknown shift. The search for understanding, the willingness to revise old models in the light of new discoveries, is the mark of modern science. Webb is revealing that the universe is still in many ways uncharted, and that true exploration means embracing uncertainty and wonder. And so, as the James Webb Space Telescope continues its exploration, probing ancient galaxies, mapping dark matter's web, detecting planets around our nearest neighbors, it carries us further into the unknown. The quest to understand the universe will never be finished, for each answer Webb provides raises a host of new and deeper questions. What other mysteries remain? How many more impossible objects will shimmer from the darkness, awaiting detection? The silence of space is not empty. It is filled with stories just coming into focus. This journey into the cosmos, into the heart of impossibility, is just beginning.